Hi, this video is going to be about understanding two-step equations. So we will be talking about how to solve two-step equations and what properties should be used when you're solving two-step equations and what steps you should take in solving two-step equations. If you are not yet familiar with the properties of equality, there is another video about the properties of equality. So ask your teacher about learning about the properties of equality before watching this video. You could also look them up on Google and take notes on them so that you have it ready for when you watch this video, because I will be saying things like I'm using the addition property of equality, and you need to understand what that is in order to understand what the video is talking about. So you could pause this and look those up, or ask your teacher for the video and information related to properties of equality. Also, if you are not familiar with what additive inverse or multiplicative inverses are, there is a vocabulary sheet that goes along with this video and worksheet that you can ask your teacher for. So make sure, if you're not familiar with additive inverse or multiplicative inverse, that you ask your teacher for that, and then once you fill that out, have it ready next to you while you're watching this video, so when I say things like I'm creating an additive inverse, you understand what I'm talking about. We are going to look at solving these two equations side by side so that we can compare and contrast the properties and the steps that are taken to solve these two different equations. The first equation is 2x minus 3 equals 13. So we'll start this equation by rewriting the equation here and cutting the equation into two sides. So just kind of cut down the equal sign so that we can see there's a left-hand side and a right-hand side to the equation. We must keep this balanced so that both sides remain equal to each other. In order to do that, we will be using properties of equality. So the first thing we need to recognize is that we're trying to figure out what x is. We don't know what x is right now. We know that 2 multiplied by x, if you subtract 3, the answer is 13. But we don't yet know what x is. So we're going to undo some of the operations using the properties of equality to get x by itself. So the first thing we're going to undo is the subtract 3. That's pretty easy to get rid of. So we're looking for something that is the additive inverse of minus 3. Well, the additive inverse of minus 3 is plus 3. So the reason we call that an additive inverse is that it creates a situation where negative 3 plus 3 is 0. In order to keep the equation balanced, we're using the addition property of equality, and so we will add 3 on the right-hand side as well. So negative 3 plus 3 is 0. That's why sometimes you'll hear people say, well, the 3's cancel. Well, they don't cancel, technically. They result in an answer of 0. So I could write 2x minus 0. But since there's nothing there, usually no one will write minus 0. So they will just write 2x because that's all we have remaining on the left-hand side of the equation. 13 plus 3 is 16 on the right-hand side of the equation. All right, so now we're closer to getting x by itself. So now we need to use a property that can create the multiplicative inverse of 2 so that we can get x by itself. So 2x means 2 is being multiplied by whatever number x is. So to create a multiplicative inverse, I can use the division property of equality and divide both sides of the equation by 2. That way, by dividing by 2, I have a situation where 2 is being divided by 2, which is 1. So, sometimes people will write 1x because 2 divided by itself is really 1. So by using the division property of equality, we created a situation where we have the multiplicative inverse of 2. So now we have 1x. So anything times 1 is itself. So most times you won't see people write the 1. You will just see them write the x. 16 divided by 2 is 8. And now we have x by itself, and we have solved the equation for x. Okay, now we're going to look at the next equation, x divided by 2. So remember that any time you see a fraction, you're also looking at a division problem. So x over 2 is the same as x divided by 2 plus 3 equals 7. So x divided by 2 plus 3 equals 7. So we need to get x by itself again, and we need to create an additive inverse for plus 3. So there's kind of two ways you can think about this. You can use the addition property of equality, and you can add a negative 3, and that will create an additive inverse for the plus 3, because plus 3 plus negative 3 will give you 0. You could also use the subtraction property of equality and look at this as subtracting 3 on both sides of the equation. So you're using the subtraction property of equality, but you're still creating an additive inverse situation where plus 3 minus 3 is 0. So with that being 0, on my left-hand side of my equation, cut it down the equal sign, I have x divided by 2 remaining, and 7 take away 3, which is 4. All right, so now I need to create a multiplicative inverse with x divided by 2, so with the divided by 2. So a lot of times students will make the mistake of dividing both sides by 2. So you really need to understand the properties of equality and what you need to create, which is a multiplicative inverse to get x by itself, to do this problem correctly. So that's one of the reasons why it's so important to know the properties of equality and to use them, and to use multiplicative and additive inverses. So let's take a look at another way to write x over 2. Another way to write x over 2 is to write 1/2 x. Because 1/2 x, if you multiply 1 times x, you get x, and then you're still left with 2 in the denominator. So 1/2 x is the same as x over 2. It's an equivalent way of writing x over 2. Okay? So if we have 1/2 x, how do we create a multiplicative inverse with this situation? Well, the way we do that is by multiplying by 2. So now we have a situation where we have 2 in the numerator and 2 in the denominator, and now we have 2 basically divided by itself. The same situation we created on the left-hand side here. It's just that on the left-hand side, we used the division property of equality because we were trying to create a multiplicative inverse with 2 being multiplied by x. Well, x is already being divided by 2. So to create a multiplicative inverse, we need to multiply by 2 on both sides. So 2 divided by 2 is 1, and now you can see I'm left with 1x. And again, x times 1 is x, so we just leave it as x. So we need to do the same thing to the right-hand side. We need to multiply by 2. So here's another place where students will make mistakes, is that they will divide the right-hand side by 2 because they've memorized steps and you're used to dividing to get x by itself. So again, that's why it's really important to understand the properties of equality and the multiplicative and additive inverses so you know what operation to do when, if the equation looks different, and then you understand why you're doing that operation. So 4 times 2 is 8, and now we have our x by itself, and we've solved this, and we can see that x is equal to 8. So both of these situations gave us the same answer. The equations look very different. So we're going to see why 8 is the answer to each of these, because we're going to check our work so that we can make sure that our answer is correct. It's always a good idea to check your answer so that you know that the value you say x is actually works in the equation, the original equation you were given. Okay, so here's where we're going to check our solution. So in place of x here, we're going to substitute the value of 8, which is the answer we found to this equation. So instead of 2x, I recognize that's a multiplication situation, 2 multiplied by x. So I'll use parentheses to show multiply. So now we have 2 times 8 minus 3 equals 13. So follow the order of operations. You need to multiply before you subtract. So 2 times 8 gives you 16 minus 3 equals 13. 16 take away 3 is 13. That is equal to 13. And so our solution checks out. 13 equals 13, and that statement is true. So it tells us that our original input for 8 was correct. Now let's take a look at the second equation. We have x divided by 2. So that will give us 8 divided by 2 plus 3 equals 7. So follow our order of operations. We're going to divide before we add. So 8 divided by 2 is 4 plus 3 equals 7. 4 plus 3 is 7, and that is equal to 7, so our answer checks out. So the fact that the answer, or the x value for each of these equations was 8, it does not mean that these equations are the same. It just means that for both of these equations, a value of 8 is what makes the equation true. 8 could be the solution to many other equations as well. So we have shown here that our answer checks out for both of the equations and that we have the correct solution. Now you are going to be taking a look at 3 different problems that 3 different students worked out. So you're going to see the student work. Your first problem looks like this on your paper, and you can see that the student got an answer of 13 divided by 2, or 13 halves. So the student made some mistakes. So did this student. The second student made some mistakes. They got an answer of 7/3. And this student made some mistakes. So make sure that you're going to work through each of these 3 problems to discover the mistakes that the students made. In your explanation of what the student did wrong, you want to use your academic vocabulary. So you want to use terms such as additive property, addition property of equality, additive inverse, multiplicative inverse, division property of equality. So if you're saying that someone made a mistake, a good sentence starter would be, this student did not use the addition property of equality. This student used the subtraction property of equality, and that was incorrect because the subtraction property of equality does not create an additive inverse. So that's just a sample of a sentence to kind of get you started thinking about what you're going to write in your explanation. So make sure you use academic language and you use complete sentences in explaining what each of these 3 students did incorrectly. So there's a space on your paper for you to work out the correct solution, and then you can compare and contrast the operations you did to what the sample student did. And keep in mind that all 3 of these students made at least 1 mistake. Some may have made more than 1 mistake. And then after you're finished with this, you can turn your paper into your teacher so that they can see what you have written and what your explanations are for their mistakes.